Welcome to the class, dear students. In today's lecture, I am going to explain you about the integral test. When do you say that the infinite series summation n is equal to 1 to infinity an is convergent? That means this integral test tells that you take this an, whatever the nth term, we will represent by the function f of x. So integral 1 to infinity f of x dx is finite, suppose, then the series is convergent. And if this happen to be an infinite, suppose, then this becomes a divergent series. Okay. Now let us see the problem now. That is summation n is equal to 1 to infinity e to the power of n by 1 plus e to the power of 2n. By using the integral test, we are going to solve it. So first what we have to do, we consider this function f of x as just in the place of n, you are going to write x. That means e raised to x by 1 plus e raised to 2x. This is your f of x. Now what is integral? What is that you have to consider now? Consider integral 1 to infinity f of x dx. So what is this? Integral 1 to infinity f of x is e raised to x by 1 plus e raised to 2x dx. Now what is t here? Now because now we are going to substitute, you are going to do the integration now. So what is how to do this integration? By taking the substitution. So let us take t is equal to e raised to x. Then what is dt? dt is e raised to x dx. Okay. So what we are writing? This e raised to x dx is being replaced by dt. Okay. Now what is your 1 plus e raised to 2x? How will you write this? It is 1 plus e raised to 2x can also be written as e raised to x the whole square. So what is this value? Is 1 plus e raised to x is t. So it is t square. 1 plus t square. Clear? So now what is this integral value? Is integral 1 to infinity e raised to x dx is dt over 1 plus e raised to 2x means 1 plus t square. Okay. Now what is the integral of 1 by 1 plus x square? We already know that it is tan inverse of t. Tan inverse of t within the limits 1 to tan inverse of t. Now in the place of t, you have to replace what is the value of t and then you have to replace the value. So tan inverse of t means e power x within the limits 1 to infinity. So that gives you tan inverse, the upper limit is what? E power infinity minus the lower limit is 1. Okay. Now what is tan inverse of e power infinity? Is infinity. So it is tan inverse of e power infinity and this is e power 1, sorry. This should be e power 1, okay. Minus tan inverse of e power 1 means e, okay. So the value of tan inverse of infinity is pi by 2 minus tan inverse of e. This is of course a finite value. Our job is to find out whether it is finite or not. So it is finite. So when the integral is finite, the series summation n is equal to 1 to infinity e power n by 1 plus e power 2n also converges. If the limit is finite, then we say that the series is convergent. Let us see this problem now. Here, what is an? An is 1 over 2n minus 1. So what we can write about f of x? F of x is 1 over 2x minus 1. So what you have to consider now? Consider the integral 1 to infinity f of x dx. So what is this integral 1 to infinity? F of x is 1 over 2x minus 1 dx. So now what is how to do this integral? Put t is equal to 2x minus 1. So dt gives you 2 dx. So dx gives you dt by 2. So let us substitute all this. Then what you get? Integral 1 to infinity 1 dx is what? Dt by 2 into 2x minus 1 is t. So dt by 2t. So what you can write it as half of integral of dt by t. What is integral 1 to t, 1 to infinity dt by t is ln t. So it is half of ln t. Now many students do the mistake here that by replacing t your limits 1 to infinity. It should not be done. Please concentrate and focus and use your substitution after the t. Now ln of 2x minus 1. So the limits are from 1 to infinity. Now what we can do now is ln of infinity, 2 into infinity minus 1 is ln of infinity, minus ln of 2 into 1 minus 1, that is 2 minus 1, that is ln of 1 is 0. Whatever this value may be, ln 1 is of course 0, but ln of infinity is always infinity, and therefore this is an infinite value. So what we can say, since the integral is infinity, the series summation n is equal to 1 to infinity 1 over 2n minus 1. 1 to infinity 1 over 2n minus 1, this series diverges by the integral test, because all the infinite value you got for the integral, and hence it is a divergent series. I hope you could understand. Thank you. With this we have completed the total infinite series chapter, where in the first few lectures we have done where for what values of x the given series is convergent, especially the given geometric series is convergent. Now in present lectures, in the last couple of lectures, I have explained you how to solve the convergency of the series by using the root test and then the ratio test, and in today's lecture I have done the integral test. So with this we have completed the infinite series topic. Thank you.